Hey there, ladies and gentlemen. Going to go over the predicting products review sheet for you before your test. You need to pay attention. I'm not going to leave you enough time to write everything down. You should have already done your homework. You really should just be paying attention and trying to understand things here, not learn from the start right now. So the first question was write the letter equation for each of these types of reactions, which we've seen these dozens of times. Double displacements, when you have a metal and a non-metal, a metal and a non-metal, and you're switching the metals around so that they end up with the oppositely charged ion that they're not currently paired with. Single displacement, we have a single element that's replacing one of the other single elements. If it's a metal, it might replace a metal. If it's a non-metal, it might replace the non-metal. Make sure that you check activity series. True? Right? With the single displacements, you have to check the activity series. If the single element is higher on the list, it will replace the lower element. If the single element is lower on the list, then you have no reaction. Synthesis reactions, we're combining them together. There might be one of two basic patterns. And decomposition, we're breaking a compound apart. Again, there might be one of two basic patterns. With both of these, you're going to be given that synthesis decomposition sheet along with your test. So feel free to look at that as needed. What are the basic formats for two types of combustion reactions? It depends on how much oxygen there is. So if the oxygen is in excess, and the hydrocarbon is burned, and we make carbon dioxide and water. If there is a limited supply of oxygen, then we make carbon monoxide and water. How do we determine the states of matter for compounds or elements? Good question. Wish we knew the answer to this one. Well, no, you know it. We use the solubility rules. We look at the common states of matter for elements. We have periodic tables around the room. The one that's color-coded has the metals as black, the non-metals as blue. Sorry, start that sentence again. The states of matter: solids are black, liquids are blue, and gases are red. And we don't care about the white ones. They don't really get involved in our reactions very often. What if it's water or carbon dioxide? Most of the time H2O is a liquid, unless we've got a combustion reaction. These combustion reaction water molecules up here, they would be gases because you're burning the hydrocarbon and there's enough energy to turn that into a gas. But generally the water is a liquid. Carbon dioxide, carbon monoxide, those are both gases because they're gases. Okay, let's go to the types of reactions here. Let me see, this is a double replacement reaction right here. We have magnesium and hydrogen switching places. There ends up making water. We have to switch the ions, balance the reaction, and then changes, we're making a liquid, so that is a reaction. Number two is also a double replacement. I guess both of these are also technically acids and bases because hydroxide makes it a base. Starts with a hydrogen, so it's an acid, and the base is neutralizing the acid, which is why we see water being made in both reactions. Number six, there's an excess of oxygen, so that is combustion. Alright, that's a combustion reaction. There's excess oxygen, so it's complete combustion. We have carbon dioxide and water. After we write carbon dioxide and water, we then have to balance it. This one is a royal pain to balance because the numbers are so high. I started out with 8 carbons. I had an 8 here in this position, here, and then I was like, well, there's 8 hydrogens, so I had a 9 there, but when I added them together, I only had 13 and a half. I had 12 and a half for my coefficient right here. And then I had to double everything back up afterwards. So the number 7, note of the double replacement, I'm making a solid that is 10 sulfide and acetic acid. 10 sulfide is insoluble on the solubility rules. One issue with this one for a lot of people is they're not sure what charge to use for 10 in this compound. Well, over here the 10 is a +2, so if 10's a +2 here, we're going to bring that +2 charge back with us. So the +2 charge for 10, we're going to assume it doesn't change its charge. And so when it bonds with the sulfur, which is a -2, a +2 and a -2 cancel each other out. So there's our compound 10 Roman numeral 2 sulfide. Number 8, this is a single replacement. It is a single replacement, and we said a little while ago with single replacements we have to check the activity series. Bromine is a non-metal, so we have to check the non-metal activity series list. And since bromine's a non-metal, we compare it to iodine. It's also on the list. Bromine is higher, so it replaces it. When we do that, we use the charges. Hey, Mr. Murphy, how'd you know iodine was a solid? Again, states of matter for elements. We look at the periodic table. We look over here, we'll find iodine is in black, and black means it is a solid. Let's look down to the next one. Zinc and oxygen. One element. That sure looks like a synthesis reaction. Yep, 2 elements coming together. And when we put the 2 elements together, we have to follow the charges. I give you a big hint here. Zinc is a +2 in compounds. Oxygen's a -2. There is our compound right there. How'd you know it was solid? I checked the solubility rules, and it says oxides are always insoluble, but also there's no water in this reaction, so this is probably going to be a solid. It can't be aqueous without water, right? Number 10, we have a synthesis reaction. We have sodium oxide and water coming together. So with a lot of these synthesis reactions, we might not be positive what to do. So I see sodium, oxygen, hydrogen and oxygen. So if I look at the reaction sheet, I accidentally happen to have this exact sample in the sheet. But let's see, we have a metal, we have sodium and oxygen, oxide, and water, forming a base. Bases have hydroxide in them. So that's what's going on there, is that they're combining together to make a metal with hydroxide. So there's hydroxide right there. There's a metal with hydroxide, sodium and hydroxide together. So that's what we're supposed to do in this question. We're supposed to put them all together and balance it. See, number 11, we have a double replacement. Pretty simple, like we've seen. We're making water again. 12, we have sodium chloride being hit with electricity. That's going to break it apart. That looks like a decomposition reaction. Let's see, decompositions. That's heated. That one's heated. Some decomposition reactions are produced through electric current. So electric current hits the molecule and breaks it apart. Electricity hits the compound and breaks it apart. When we break the compound apart, we do have to think about how that element exists when it's alone. Chlorine is one of the 7 elements that has to bond in pairs of 2 if it's alone. We usually call them Hofbrinkels, so it's Cl2. And it's a gas. Sodium's a metal. It doesn't have to bond to itself. It is a solid. 13 is a single replacement. Chlorine's a non-metal. It's higher on the list. Sorry about this symbol here. I don't think you guys know that is a symbol for heat. So let's just throw that on there. So the calcium chlorate is being heated. Definitely a decomposition. And it's calcium chlorates. Oh, here we go. Metallic chlorates. Calcium chlorate. So what a calcium chlorate's going to become calcium chloride. So it's going to be Ca and Cl together and oxygen. So go back here. So I put Ca and Cl together, and oxygen by itself. Oxygen has to be O2 when it's by itself. Calcium and chlorine, we got to use the charges. So I had CaCl2, and then I had to balance it. There were 6 oxygens, so I put a 3 in front to get 6 oxygens. Oxygen's a gas. What about the state of matter here? There is actually any water, so it would 99% of the time it would be solid. If there happened to be any water, it would be aqueous, but it's probably a solid. But I will take either because the solubility rules say the calcium chloride would be aqueous. Here we go. Copper is higher than silver, so it will take the nitrate away from it. The silver will be by itself afterwards. If a reaction occurs, use copper +2. So I used a +2 charge on this copper when I worked out the formula. So I was like, oh, this copper's a +2. There should be 2 nitrates. And then I came and balanced the whole reaction. Here we have a incomplete combustion because oxygen's limited, so I make carbon monoxide and water. Instead of carbon dioxide, we make carbon monoxide because it's limited. And this water is a gas because we're burning, it's super hot. Double replacement, barium sulfate's insoluble, so I got a solid there. Double replacement, lead chloride's insoluble, so I got a solid there. And this looks like a decomposition, but it should say something on it, like heat. Sorry about that. So if it said heat, that would look a whole lot. Oh gosh, it actually is this example right here. So for those of you who are using this sheet at home, when you do your homework, you'll probably notice that real easily, right? But it says oxides when heated decompose, meaning you just break them apart. So, all right. I think this is the last page. Yes, it is. So fluorine higher than chlorine on the nonmetals list. So the chlorine's by itself. We have an acid. When acids are heated, what happens? Some acids, when heated, decompose into nonmetal oxides and water. And again, that happens to be the example. So you need to check the sheet. But anyway, here's the acid being heated. You make water and write whatever's left afterwards. Here we have a non-metal with oxygen and water. Let's go to the other side, synthesis. Non-metals with oxygen and water form a weak acid. You put all the pieces together. This is SO2 and H2O, making H2SO3. This one is SO3, so it would be one more oxygen on it. Number 23. We have another no reaction. Iodine is lower than chlorine, so no reaction would occur. We have one minor typo in there. That should have been a solid, shouldn't it? Sorry about that, folks. The iodine there should have been a solid. If on the test you find yourself with a no reaction, don't be worried. There are a couple of no reactions hiding inside the test. And then the last question, we have a metal with oxygen and water. These both have oxygen in them, so they're some sort of synthesis reaction. Oh, there it is, right there. That's the example, actually, verbatim. But again, metals with oxygen and water form bases. Bases have hydroxide. So we took the charge of calcium. Calcium has a charge of 2+, and hydroxide has a charge of 1-. So there must only be 1 calcium for every 2 hydroxides. We put it together. So check the sheet when you deal with decompositions. There you go, ladies and gentlemen. That is your review sheet. You need a periodic table. You do not need a calculator and the test. So put everything away. Good luck.